Hi, in this section, we are going to discuss about the binary search tree traversal. So, we already discussed about the binary search tree traversal and its broad classification, etc. So, this video we are covering the coding of the tree traversal. So, let's start that one. So, as unlike the other data structures like linked list arrays, they are linear in manner. In the sense we can we can move from the starting node to end in only one directions or backward direction. That is, we can say that either to forward or backward. So that is, we can say that is a linear. But in the case of the tree data structure, the path or the movement or the traversal are different. Okay, so that is broadly it is classified into two: depth first traversal. Okay, that is again divided into multiple. Okay, so the depth first traversal, actually what it is means that it's this is basically classified like the way that is the traversal and the visiting the node, each node. So the name itself, we can, I mean, remember that what is it mean by the depth means from the top to bottom, correct? So this is the way that is the traversal happening in the here. It is the 5 is the node, and the tree visiting or the node visiting is from the top to bottom. Okay, so always the tree traversal is starting from the root. Okay, here the root is the 5, so it's starting from the 5, that is the root node, and the bottom of the tree. Okay, so depending on the visiting of each node, okay, then the depth first traversal are categorized into 3. Okay, so here first we can see that in order tree traversal. So in order tree traversal, what it means by the traversal is start from the node, root node. Okay, and then it will visit the leftmost bottom one. In the sense, if we start from the fifth, then it will check whether this fifth has the left child. So it has, in this case, that is the 3. Then again it will check whether the 3 has the left child. Yes, it is. In this case it is 1. And whether, then again it will check whether this 1 has the left child. So in this case it is empty, or we can say the 1 is the leaf node. Then this 1, the node 1 value will be printed. That is the value here, it is printed as 1. Then it will print its parent. So what is the parent of that? Then the parent of the node 1 is the 3. So that is what here it is printed. Then once a subtree is, this we can say, this is we can say as a subtree. So once the subtree's left nodes are visited, then it will start visiting the right node. So it will go to the first right node. So if here it is only one node is there, so that is what it is. It is a 4. Again it will check whether it has the left node. So it doesn't have any left node. Again it will check whether it has the right node. That is also doesn't have. Nothing will have. So what it will print? It will print the node itself. That is printed here, 4. Okay. Then once the subtrees left nodes are printed, parent printed, then what it printed? Then the right node is also printed. Then it will print it's super. These subtrees, I mean, one above parent will all print. So that is what is 5. So here 5 is got printed. Then again it will start. So these 5s, or here it is a root node. These root nodes, all left child are printed. Then it will start moving to the right hand side uh, node to print. Okay, so here it will go first, it will go to 15. So it will check whether 15 has the left node or right node, and first it will check the left node. So it has the left node. Then it reaches the 10. The 10 is again will check whether this has a left node. So it doesn't have any left node. So what it will do, it will print the 10. Then it will check whether it has the right node. So it doesn't have any right node. So what it will do, it will return that everything is completed. Then it will print its parent. So that is got it 10 printed, then it is got 15 got printed. Then this 15th left node, all left node got printed, then it will start to write printing the right nodes. So it will start to visit the 20, and it will check whether it has the left node, any left node is existing. So it doesn't have any left node, so this will print the 20, and it will check whether it has the right node, nothing is there, so it will go back, or in this case it is over. I mean, there is no other node to visit. So this is how the tree node print, I mean printing happening. So we can say that the way the node visiting and the printing, or we can say the way the difference is between this depth first traversal categories are different, how the node is getting visited. Okay, so let's start the coding part, and we can debug that in more details. So here I have one class I created in this package, tree package. Its name is binary tree traversal, and we already covered that the binary node, how it look like. So this is how it look like. It will have the value, and it will have the 2 pointers pointing to the left node and the left side and the right side, and this value is getting populated from the constructor. Okay, so we already all seen the how the data records are inserted, so that we already discussed in my previous video. If anybody didn't watch that one, I will suggest you to watch that first, then it will be easy to follow these further sections. So here we created the binary search tree, so we can exactly, it will be same as this representation, and then we are going to start the InOrder traversal. So I'm just uh, commenting other traversals. So I will print that one and commenting the rest of the code. I commented out. Then let's see what how it is getting printed in the. Here we can see that we already discussed about how do the node visit. Okay, so how do the node visit in the InOrder? It will visit the leftmost child. Okay, so first it will check whether the node is null or not. If it is null, then there is no pointing further continue, so we will return there itself. Otherwise, what will happen, it will it will travel to the left node. So we need to reach the left node here. So initially we will be here fifth node. In this example it will be the fifth node, then we need to go to the left node, correct? Then again, so this is the first iteration. Then the second iteration, again we will check whether this has the left node, so again it is there, correct? So similar way here is also what will happen, it will check first, it will check whether it is a null or not. If it is not null, then it will go to the left node. So here it will be left node will come, then again it will keep, I mean we are calling or we are printing this recursively. Okay, so we can do by debugging this code, that will be more easy for understanding. So we can see that the node is already populated with the values from the previous code or previous class whatever we discussed. So this is already populated. Node has the root as the 5 is the value, and it has the left and right, and left value is the 3, and left will be 1, left's right will be 4. Okay, that is the case of the left node. Then the right node will have the 15 as the value immediate child, then the 15 has the left node, that is the 10, and 15 has the right side, that is the 20. Okay, so this node is already populated. So here we can see this node value will be 5, and then this condition is false, and this is going to visit the leftmost child, I mean left child. So what is the left child? So node's left will be 3, correct? So I'm just skipping this breakpoint. So it came, so we can see that this is the 3. Again it will visit the same it will visit the same. What is the same means? In 3 is left. 3 is left. What it is? 1. So we can see I'm putting one more breakpoint. So it will be 1. This condition will check node is null or not. So it is a false. Then it will come again. So node first left. Then again this first node left will be getting passed. So you can see here as well. Each recursion there will be one method stack is also will get increased. So we can see that this is node null. From where this is getting called, if we go one below frame, stack frame here, from here the null is generated. From here means what it is the value, its value is 1. Once left is getting passed here from next below one frame, we can see from where the 1 is getting, that is got from the third. From where the third is getting, just click that below, you can see that it is from the fifth node. Okay, so here now we are at the null. So if it is a null, this condition is already returned. So that means we return back from this point. We already reached the node 1, then nothing is there, then it will return to, it return into the parent. Okay, so it's nothing is to visit, then it return, then it's returning. Then what will happen, if every left is visited, then it is going to print the node value. What is the node value here? 1 will getting printed. Okay, 1 got it printed. Then it will see, this is the one got printed. Now we need to check whether 1 has the right side. Okay, so that is what here is going on. Okay, whether it has the right side. So again it is going. So you can see this is null. You can see from where this frame is generated, just click below. You can see that this is the once, then this is the current frame. You can see here. So in this case it is null. Nothing is there. Correct. So this frame is completed. Okay. First node completely. Then we reached the third node. Okay, then we are going to print the third node. So that's why the third is getting printed. Again it will, thirds left side, all left side are printed now. Then we are going to print its thirds right. What is the thirds right? Thirds right will be 4. You can see that when we call the recursion, one more time frame will generated. See, it is get added one more. So you can see that is 4. Now we need to check whether this is a null or not. So this condition will be false. Then force left we supposed to check. So you can see that force left we need to check. So that is why we are again calling the same method recursively. Then nodes left is getting populated. So we can see there is a null, nothing is there. Then what we will do, 4 will getting printed. We can see the 4. After 4's left got printed, left we check, nothing is there. Then 4 is getting printed. Then 4's right is there. We need to know whether 4's right child, any right child is there. Here we can see nothing will be there. So you can, here the time frame also we can see nothing is there. So that completed. So 4's completed means we will reach the fifth node. Correct. So then we need to print why the fifth node? Fifth all left subtree we already completed. So we need to print the fifth node itself, value itself. So that is getting, fifth is getting printed. Then again it's going to check fifth right. Okay, fifth right will be 15. Then again the 15th left nodes we need to check. That will be the going to check. See, 15th left we need to check. We check the 15th left, that is the 10. Again we need to check whether 10th left is there. So 10th left is null. Correct. So it will be null. You can see this will be null. From where we get it? You got it from the node, that is the 10. Okay, so the current framework is the null. It return. Then if it return means then we need to print the 10 printed. After the 10 got printed, we need to check whether 10 has the right node. So we can see there won't be any right. So it will return back this framework. This frame is also reducing 1. Okay, now this will be 15. So left child got printed, then 15 is supposed to get print. So 15 printed, then 15 is right child. What is the 15 is right child? 20. Again 20 is left child, we need to check. This is got checked and completed the program. Okay. So we can say that this is how we got we got printed, I mean this node, that is the InOrder traversal. Okay, next we can see the PreOrder traversal. So what is the difference between InOrder and PreOrder? InOrder, we know that we need to visit the bottom, no, bottom node of the left side. Okay, then every left bottom node we visited, then that will get printed, and then its parent will get printed, then its right hand side will get imprinted. In the pre-order, the order of visiting will be different as compared to in order. So here, as the name itself mentioned, it's getting printed, I mean, prior to moving the or prior to traversal. Okay, what it means is that as I mentioned, every traversal will start from the root node. So this is getting started from the fifth node. So we starting the fifth, then immediately it should print. That is the 5. Then we are visiting the left child only, left side. Then we are visiting the left child. Then immediately we will print that one. That is we got printed 3. Then it's third node 3. Its left child is the 1. Then that is getting printed here. After we also check whether node 1 has the left child. If nothing is there, we'll check its right node, anything is there. That is also nothing is there. So this is completed. This is again returned to parent. Then we checked the left side of the 3. Then we need to start the right side of the 4. I mean right side of the 3. So right side of the 3 will be the 4. So that is getting printed. Then we'll check whether this has left node, nothing is there, so it will return. Then also we'll check it 4 has the right node, nothing is there, that is got returned. Then all the node under the node 4 we already visited, then the pointer will be returned back. After returning from the right side of the node 3, it's every node are already visited, this return back to its parent. Third parent is the 5. So all left side of the parent node, here it is the 5, all left side is already visited, then it will start to visit the right node. So fifth right node will be the 15, that is getting printed first. Then it will visit its left side. So immediately left side is the 10, that is got printed. 10's left nothing is there, 10's right is also nothing is there, so the pointer will return back to 15. And then the point, then it will start visiting its right side. So immediately 20 will get printed. 20 is left nothing is there, so it will return back. And then after returning, then it will check its right side, nothing is there, so the nodes 20th nodes both side left and right completed. Then pointer will visit to, I mean pointer will pass to 15th, that is its parent 15, so that is the right side. So all node of the 15th visited already, so that pointer will return back to the 5. And the fifth node, that is the root node, all node now currently visited, so the program will over, finished. Okay, so let's check or let's debug the logic in debugging the code here. So I'm just commenting the InOrder traversal and I'm uncommenting the PreOrder, and we need to put breakpoint here. I'm putting the breakpoint. Okay, I'm running the code, debug mode. As in the previous case, the root node will be fine. We'll check its node is null or not. So as I mentioned, the node visited immediately, I mean before the traversing to the both side, the parent will get printed. So here 5 is the parent, then it should print first. It's getting printed here. Then what will happen? Then it will visit to the its left node. So what is the left node? You can see the method stack frame is also will increase while we recursively calling. So there is one increased. So this is the 5 node third will be then from where the node 3 is comes. It comes from the fifth left. Okay, and it will check whether it is a null or not. It is not null, so this condition will not be true, and it will print the third value. Then thirds left is also we need to check, so it will check whether it is a null or not. So it is a 1, so that 1 will get printed. Then it once left, that is null, so nothing is there, it's over. Then it will be returned back to 1. Then once right will start, once right anything is there, nothing will be there, so it is returning from the first. Then this is from where it started. It started from the, you can see it is started from the 3. So now it's from where it is the node, I mean it is a node 1. So both the pointer left and right already visited, so it is returned back to third parent 3. Then after that it will start node 3, node third, it's a right side. Okay, then start a right side, node third right will be 4. Then fourth left we are supposed to print, I mean now 4 will get print. Then after that it's a left will check, left will be null, then nothing is printed. Then nodes right, that is also completed. Then it is, we can see here it's a 5. So fifth, the node 5 or its left side is completed. Then it's starting to write, I'm printing the right side. Okay, so I'm just skipping the logic. I think already we understood this logic. I'm just skipping this. So this is how we can say that the pre-order getting printed in the programmatic. Okay, then the look into the post order. So the post order traversal, tree traversal is different from the other two. What is the difference? In the in order, what will be the scenario? The scenario is like that: leftmost node will be getting printed, then it's a parent, then it's rightmost. In the pre-order, first parent will get printed, then left, then right. Here what is the difference? First left node will get printed, then right, then parent. So that is the difference. So let's understand one by one. So every node, as previous traversal also, every node, I mean every traversal will start from the root node. It start a root node, so it will visit the left. Okay, so 3, and again it will check whether 3 has the left node. Yes, it has left. Whether it has the any child node is there, nothing is there. So what it will do, it's a nothing is there, nothing will print. Okay, then it what it will print, it select, it's return, and then its node, first node will get printed, then node got printed. Okay, after that its parents. Okay, it's a parent, who is the parent? Third right will be getting printed. Okay, so how it will be? The third's right means it will come to the fourth node. We'll check where the fourth has the left, nothing is there, right anything is there, nothing is there. Pointer will got returned back. Okay, then 4 will get printed. After 4 got printed, it will return the pointer. Then after that the node 3 will get printed. So node third, both side are got printed. Okay, then what the, from where it is getting generated? It's got from the fifth node. Okay, fifth left. Then we supposed to print, visit the fifth right. Okay, so it will move to the fifth right. Then fifth right means it will reach the 15. Then again it will it will check whether 15 has the left node. Yes, it has the left node. Then it will come to the it come to the 10. It will reach the 10. Then it will check whether it has the left node. If it doesn't have the left, then it will check whether it has the right. Right is also doesn't have, both pointer will return, then the 10 will get printed. Okay, from where 10 is generated, 10 is getting generated from the 15th node, I mean node 15. So it will visit the 15th right side, so this node reach. Then it will check whether the 20 has the left node, nothing is there. Then it will check whether right is there, nothing is also there. The pointer, both pointer will return here, then 20 got printed. So the both side, that means 15th left and right already got printed, then the pointer will return to 15, then the 15 getting printed. So already the left node is already got printed, this right node is also printed for this node 5, then the 5 is getting printed. After the 5, this nothing is to visit in this data structure or this tree, then the program is completing. Okay, so let's check the coding part. So here we can comment the previously we already visited this pre node. Then we can uncomment the post order, how it will be. I'm just putting the breakpoint here. I'm running the code. So here you can see that it reached the fifth node. The what is the condition? If you reach the fifth condition, it will go to the left node. It should visit the left node. So this condition will be false. It will go to the left node. So you can see the one more time. I mean framework. I mean frame will be regenerated. It's fifth. This will be 3. Then again third left. It will be 1. Once left. Okay, nothing is there. Correct. So the ones, then it will visit the right, nothing is there. So the node 1, its left and right is already visited. After that the node will get printed. Okay, so it got printed, first node printed. So from first, where did the first come from? It come from, if you check this time frame, you can see that this is coming from the node 3. So node 3 left was that, then node 3 is right supposed to finish. So we need to complete the left, then its right is getting. So what it will be? It will be 4. 4's left, nothing is there. 4's left, nothing is there. So 4, node 4, all both side are visited. Then it is getting printed. 4 is getting printed. So 4 is generated from the third node. Then third left and right is already got printed. Then third got printed. From where this third is generated? Okay, third is generated from where it will be. If you click the below frame, you can see that is generated from the fifth left. Then fifth right we supposed to visit. Then fifth right, what is the fifth right? Fifth right will be 15. Then 15's left we need to check. Okay, 10's right, I think then 10 will get imprinted. Okay, so this is how the visiting of the post order traversal. So I'm just skipping this. So it got printed the order.
If you like the video, please click the like button and subscribe for more videos.